Yeah, so it's tricky because part of this is from how we're marketing and communicating about the degree. We see a lot of econ, a lot of public policy degrees. We see, probably around 3 to 4 years of work experience is around the average. Some CS and stats who want to, get depth. Again, the advantage of having a full CS department. If you come to with a computer science degree, we can waive courses and just keep the harder ones and still give you the policy perspective. But that not as much, and that's not surprising. I mean, one of the reasons we need programs like this is there is no pipeline of traditional computer science classes or programs into tech, into public service. So the estimates vary, but we think it's like less than 10% of people who come out of CS degrees go into the nonprofit sector or the public sector. So big governments and nonprofits are 30% of the economy, and less than 10% of CS graduates are going there. So we're not getting CS graduates coming much, a couple. We get some stats, some econ, public policy, sociology, a lot of degrees like that, and then maybe 3 to 4 years work experience around there. Yeah, this.
Do any of your graduates go on to get PhDs with the same department, or is this aimed only at people who want to work in policy?
We have had 1 or 2 people go on to get a PhD, again, small sample size, 25. We don't have a PhD yet. Other than the Carnegie Mellon program, which is machine learning and public policy, and I think there's a stats and public policy PhD, we're both very small. I'm not aware of any in this field that are full PhDs explicitly in that overlap. I'd be interested in learning about that. Wrong, please correct me. Okay. Thanks. I'll be around.
So our next speaker will be Engler from Metis, who's going to talk to us about the bootcamp perspective on education.
Hi everyone. So my name is Zach. I am a senior data scientist / teacher at Metis Bootcamp here in Chicago. The first thing I'm going to do is kind of orient everyone to bootcamps. I know there's a lot of weird information about bootcamps out there. I'm fully aware of that, so let's just talk about sort of what I do. So we are data science and machine learning educators. And in particular, what we do is offer a 12-week intensive course, which means that it's 9 a.m. to 6 p.m. Every day of the week for 12 weeks total. And we'll talk about sort of how we break that down coming up. And to be perfectly blunt, we're not quite a 0 to 60 program. So what we do is we interview all of our students beforehand, and the expectation is they come in with a little bit of coding knowledge and a little bit of statistics knowledge. So, can they take a derivative? Do they know what a Gaussian distribution is? Have they ever seen Python once in their life and can write a small program that doesn't break? Those are the types of things that we look for. And because we know that 12 weeks is a ton, there's not enough time to pack in a ton of information, and so we have to sort of make sure that they can hit the ground running. But what it is more of a 20 to 80 program. And what I mean by that is yesterday, I was teaching stochastic gradient descent. So they come in, the first week we do Python, refreshers, what is the Python data science stack, and then in the next week we jump right into linear regression, gradient descent, sort of all of the underpinnings of your traditional machine learning models, and also how do you manage data and things like that. And then the next day, while I'm here, my compatriot is teaching with web scraping. So it's sort of, if you can have the basis, we're going to grab you and then sort of accelerate up to being able to be sort of a junior data scientist level when you're done. And our goal is to be a very practical approach. So it's sort of practical but deep enough. So like I said, we talk about gradient descent, but you're not probably going to be able to invent the next algorithm when you leave our bootcamp. But we tend to see sort of two genres of student that comes in. And so I'm going to sort of frame everything about in the sense of these two genres. We have our career changers, which are people that have 5, 10, 15 years of experience in some field that is not really computer science related, not really STEM related. So as the example I'm going to use later is a lawyer. We see people coming in. We had one guy that came in with, he was a grocer for 10 years, and he came into our program because he did not want to be a grocer anymore. So those are the career changers, and we also have a lot of STEM grads that come through. So people that have statistics degrees, economic degrees, things like that. Today, we're going to focus on the career changers because I have 10 minutes, and I would like to sort of make the point. But if you're interested in sort of the other side, let me know. I'll be happy to talk about it later. So what have we learned so far in doing this? The first thing that we learned is that we need to teach concepts and then help the students build something useful. The idea that we're just going to stand up in front of them and lecture for 12 weeks is really appealing to me because I have a lot to talk about, but it's not very useful in terms of when they leave our program, how good are they? So what we do is we teach for a couple hours each day, and then they build projects. And so our format is that they will leave with a portfolio of 5 projects, starting with exploratory data analysis, linear regression, classification, natural language processing, things like that. And our second thing that we've learned is that we can't just give them canned data sets. It turns out that if all you've ever learned on is the iris data set, you're not a very good data scientist. And so we avoid that. So that's why today they're learning web scraping, because for their next project, they're not allowed to use any data sets that are pre-made. Like, that's just the constraint. So it's going to teach them how to pull in data, how to clean it, how to actually do a data science project if somebody hasn't given you the data and said, please just divide these two numbers. And then, like I said, we have them build out multiple projects. So it's really a learn by doing field. So we want them to come out with a breadth of knowledge that will make them applicable to whatever business hires them. And I swear I'll tie this into social good here shortly. But we want them to come out and be ready to actually contribute, which means that they have to have seen a linear regression problem before. They have to know what classification is. We touch on things like deep learning and stuff like that, but we're really more into, like, for their final project, I'll let them get into that, but we're more into practical things that make them useful data scientists. Yeah. And then finally, we want to make use of their deep subject matter expertise. And so this is where I'm going to tie into social good. So Metis itself is not, like, we are not focused, like Alex was talking about, on specifically public policy. We have 12 weeks, people want to come in and change careers or advance to go from statistics degree to data scientist. And so we don't have time to delve into that public policy side of things. So what we do instead is we allow them to make choices on their projects that allow them to tap into their deep subject matter expertise. So, thank you. With that in mind, let's talk about how this ties into data science and social good. In order for this all to make sense, I need you to know that I am a rehabilitating physicist, like they mentioned this morning. And so what I know about, for instance, the justice system is this. It's like 7 years of my parents watching Law and Order and not letting me control the TV remote. And so I know quite a bit about this. And so what we're trying to do then is take individuals with unique passions, equip them with data science skills to make change happen in the fields that they know. Right? And so this is the exact way that we tie into the overall thing. And so, for instance, if I, a physicist, wanted to make change in the justice system, I would have to go spend the next year, maybe more, at like minimum, learning about the justice system. Or instead, you could hire her. So this was one of my students in my previous cohort. Her name is Janie Chang. She started out her career by getting a law degree. And then she decided that she was tired of being a consultant for law firms that was just dividing numbers in Excel. And so she came to our program. So she went through a 12-week program. There was quite a bit of crying. And then afterwards, we got her sort of motivated. We got her all of the skills she needed. And she joined up with a startup here in Chicago that's working on bringing data science to the law space. So they work with contracts and doing natural language processing, that type of thing. And so the way that she actually ended up meeting up with those people is that her Metis final project was Ruth Ginsburg. And so she used long short-term memory neural network, LSTMs, for those who are interested, to read and generate legal documents. So she would read documents that Ruth Bader Ginsburg had authored. She would learn about Ruth Bader Ginsburg's style of writing. She would emulate that with generative LSTM and put out basically legal opinions that were somewhat gibberishy, a lot gibberishy, but you could definitely tell that it was Ruth Bader Ginsburg. So like her opinions on topics definitely showed up when she would generate things. Now let's change gears a little bit and talk about what I know about international development. So far what I've gathered is that if you have a hand and a globe, you have a logo. So if you were going to hire me, that would be a problem, but you could actually hire Emily, who has a great poster back over here. I'm going to talk a little bit about it. She has a master's in international development. She was working with the UN on policy research, and then she joined up with Metis San Francisco, and now she works with the Gates Foundation working on agricultural development. And so her Metis final project, which is also what her poster is about, I definitely recommend you talk to her about it, is targeting disaster relief from space. So how do you coordinate disaster relief? Well, there's tons of ways you can go about it. One of the most efficient is to use satellite imagery and figure out where the biggest problems are occurring after the disaster, and then use that information to direct people. And so she used satellite images to do that. We also have a sort of a big community now of alumni. We've been at this for a few years, and we can mobilize that alumni group. So I'm going to give an example. There's the Mexico City earthquake that just happened. Our chief data scientist was born and raised in Mexico City, so she put out a call on our alumni channel and said, hey, let's work on this. And so within a few days, they had basically put together a map that shows all of the damaged buildings, puts together like who needs what help. It's organizational. She was working with Mexican government to get all of this together. We were pulling in information from Twitter. And this map was then being shared back. So this is the type of power that you gain when you have a big group of alumni that have sort of broad interests, but have all been trained to be have the data science skills to actually make something like this happen. And so that's sort of where Metis ties into the data science for social good, and the general bootcamps tie into that, is that it's a quick change, it's a quick turnaround, which is not prohibitive to people that decide, hey, I'd like to be a data scientist now, but I'm also really good at this. And so I can join those two together by gaining the data science skills and maintaining my other skills, and then jumping into the social good space. So that's what I have for you. Just want to thank you for your attention. If you have any questions, please let me know. We do have a couple minutes for questions.
So when you take these career changes, like you said you had a grocer, what kind of skills did that person come in with, and how did you work to develop that into great community?
Yeah. So to be perfectly blunt, that particular example came in with no skills. So what we did instead was, when he went through his interview round, we told him, hey, we really like all your enthusiasm, we like what you're doing. Here's a bunch of materials that we've made that are math, some basic coding stuff. Please reapply in like 2 months after you had a chance to kind of skill up in these things. And so we built him out sort of a base skill level. And then when he came in, we learned what sort of drives him beyond groceries, because groceries is not a great driving force. And so he ended up getting really big into natural language processing. And so we sort of honed all his program, like his programming projects to go more in that direction. So a lot of the times, it's about, if somebody comes in with low skills, or it's about how do we help them get to that next level so that they can actually make that change.
Are you guys all Python all the time, or do you have like tracks for SAS or R or other languages at all?
We are pretty much exclusively Python at this point, and that's not because we hate R or SAS. It's basically because we have 12 weeks, so let's pick one and make it happen. And we found that one to be more, basically comes down to the STEM side. People that come in from C++ tend to do Python a little easier than R, and we've had less resistance that way, so we chose Python.
Have you felt that your graduates are just as competitive maybe as people who come through a traditional degree program in terms of getting their job right out of the boot camp?
So far, yes. I I personally do not have like those numbers in front of me. I definitely focus more on the curriculum and education side. But we are, like, at least at Metis, we are accredited, and so if we don't place at a certain rate, we lose our accreditation. I don't have the numbers for other boot camps. I can just speak to ours, and so we basically have to maintain that. And so far, we've been able to do that pretty well. And competition-wise, especially here in Chicago, which is the market I know, we've been getting a lot of really positive feedback from employers, because we bring them in and say, hey, what would you like us to do different to make our graduates more competitive? And so far, the main thing they've been saying is, hey, add more SQL, add more SQL. And so we've been doing that and getting them ready. But I don't want to like give you a false information, so I'm not going to quote any numbers or anything.
Sort of a simple question, which is, what do you mean by your program accredited? And the reason I ask that is because my question is about funding and getting funding for students who can't afford $16,000.
Right. So we are accredited through a program called Asset, and I'm going to be honest, I don't know much about it. It's ACCET if you look it up. I just know that we have like minimum standards that we have to hit as far as of our students, how many get placed into jobs, how many are making this amount of things, how many people are still there after 3 months, how many graduate, things like that. Those are all numbers that we have to hit. And I know about those numbers, but I don't know about the program overall. Because we are accredited, they can get a loan for some amount that's just over that $16,000. Again, I'm not the guy to talk about that. I'm really on the machine learning nerd side of things, not the business side of things.
And for someone considering a career change and considering the university program versus the bootcamp model, what would you suggest they keep in mind as they choose between the two?
So this is like, not that I think you intended that, but a somewhat loaded question sitting in front of a bunch of University of Chicago people at their conference. But I would say that the thing is that if you want to get really into the research side of like machine learning and things like that, like to be perfectly blunt, our program is not going to prepare you for that. You're going to have to do a lot of work afterwards. If you would like a very quick turnaround, a 12-week turnaround with a lot of hands-on approach, you're going to build out a portfolio, you're going to have a bunch of things to show employers when you're done. Our program is right up your alley for that, and you're going to leave with enough of a depth of knowledge that you're not going to be at a disadvantage in interviews or anything like that. And that's basically how we've designed our program. We're not really trying to compete with people that are going into like deep research positions or the next level. It's, can we make you a junior data scientist, or you're not shooting for lead data scientist into our program. But can we get you to that level where you can be contributing to a business or whatever your fancy is as a data scientist in 12 weeks? And that's all we're shooting for. So it's definitely, our angle is definitely more about the turnaround time and the fact that you're going to come out sort of ready to go, but you still have some delay. Thanks, everyone.
So next up we have Janie Chang, who's going to talk to us about DSSG fellowship.
Hey everybody. I'm Jane, as Kit introduced me. I think that everyone here by now is probably familiar with the concept of the DSSG fellowship that we hold every year. We have a 12-week summer program. About 40 fellows come and work on teams. The fellows are a mixture of usually about 1/3 computer science and machine learning background, 1/3 social science, a lot of people from political science and econ, and then about 1/3 stats, which is what I was. I was a fellow 2015, coming straight out of a stats program. And then I loved all the curriculum so much, but also am a little bit obsessively organized, so I really jumped at the chance when I stayed on for the next 2 years to revamp the curriculum. So the goals of the fellowship program are, first and foremost, train the fellows to do data science for social good. So this is what might be a little bit different than some of the other talks even in this session, is we really take this kind of holistic view, that it's not just about machine learning and data science and being able to program. It really matters that you understand the context that you're working in, that you're working on a problem that actually matters, and that you learn how to work on teams and learn by doing, like Zach was saying. So the second thing that we do is try to introduce data science to the social sector. So it's not just a training program for the fellows, it's also a training program for the partners, so that they can find out what types of projects are possible. And then the third, which hopefully is being achieved by this conference, the proof's in the pudding kind of, is to build a community of data scientists for social good, so that this work can kind of propagate. So the things that are necessary to do data science for social good, it's not limited to the programming and the computer science skills, although it definitely includes those. But we think that you need both the technical skills, but also just as much the softer skills. So the communication, you're hearing from Sam and Alex from the I teams. It's really important to be able to listen to your project partners, formulate a problem that's important and not just interesting, but that people can act on. You need to know about social science and experimental design, so you know how to interpret your results and what your results actually mean. And you need to know about ethics and legal issues, both legal in the sense of your data transfers, data sharing agreements, but also the ethics that are a little bit more spongy and not as clear cut. So those are things that we think that everyone should be thinking about. So I did use the chance to make slides as really a chance to put in gratuitous pictures of DSSG staff and fellow alumni that are here and that I really like. So Kevin Wilson, I don't know if anyone was able to go to his talk, but I'm sure it was fantastic. I missed it today. But back to the actual material. Getting up to speed and being able to contribute is what we focus on in the first 2 weeks of the fellowship. So everyone comes in with at least some stats knowledge and background. Everyone comes in being able to write a Python script that doesn't break, and some desire to do social good. And that's basically the only thing that we require that everyone has in common. But after the first 2 weeks, you need to be able to hit the ground running and working on your project. So you need to be able to connect to a database. A lot of people have never used a database before or worked with real data. And so we do a kind of intensive orientation in the first 2 weeks to make sure that everyone is on the same page and knows how to use all the tools that will be required, and that they also spend those 2 weeks hearing from all of the project partners about what issues they face so that they're learning about the context around the problems as well. Learning by doing. Again, I can't reiterate this enough. It's really important that people are learning not just by toy examples. It's we love looking at the Chicago open data portal data sets and kind of doing these toy examples on the food inspections things, but really working on the real problems, working with messy data, and addressing security issues. All of those things are really important. And the skill of learning to work on a team is really critical as well. This is a picture from this summer, DSSG Lisbon, or a series of pictures. One thing that I think is really important is that we don't teach everything, although the staff teaches some of the stuff, but that a lot of the fellows are learning from each other. It's an incredible group of people with so much knowledge that we think it's really important to draw from. So we do fellow teach-outs, usually about twice a week. So I see Helga in here. I get to call her out again for the second time today. But she did one that was probably everyone's favorite of all time. She did an antimatter teach-out, so it pays to have reformed physicists around. And then which keep going back to, and which I think is just really brought home by the existence of this conference, it's really important to communicate everything that you did. So a lot of people come into the data science fellowship, especially from academic and more technical backgrounds, and say, it doesn't matter if I can communicate my results as long as I'm right, basically, or don't think that it's important to be able to communicate it to both technical and non-technical audiences, but we disagree. So we think that's really important for everyone to be able to communicate the technical side of your work, but also to be able to tell your partners what it is in a more business sense and tell them exactly what you're doing, and then to also be able to talk to a wider audience. And it's important to talk to a wider audience about these projects. And then this is the very highest level talk about the curriculum, but it's all online on the DSSG GitHub. We have the Hitchhiker's Guide to DSSG that includes both the manual for DSSG, which has the code of conduct and a little bit of information about how we set up the fellowship, as well as the actual Jupyter notebooks in the programming lesson. So this is both for, in the spirit of open source, but also this is for as the DSSG global network expands, so that other people can set up similar fellowships, and hopefully that someone can follow along at home and get some of these skills even if they can't join us over the summer. So Avishek and I have put a lot of work into, you'll hear from him next, but we put a lot of work into this repo, so I would really invite you. My call to action is to please check it out. It's a huge work in progress, hence my little yellow man, and we really want to get everyone's feedback, tell us what makes sense, what links are broken, because I break links every week, and hopefully, this is like the pipe dream, is contribute some of your own materials so that we can grow this. Thanks. One more thing. Find me if you have any questions. I'll talk about it the rest of the day. I would love to talk more about it. Oh, or ask me questions now.
Let's say that there's someone who has a background in like computer science or data science, and they're kind of entering like the social field. I think someone mentioned earlier it was like less than 10% of tech people make it into like the public sector. So what would be the value of doing this program rather than just kind of entering the field and learning within that field? Like what would be the value in coming to a public policy program if you already have like the technical background?
Yeah, I think, did everyone hear the question? No? No? Okay, so the question was, if I can paraphrase, if you're coming from a more computational, like computer science background, what is the advantage to doing a program such as this compared to you just going into the social sector and working there? And I think my immediate response is that the types of people who are going to be doing those two things would be different, because we are sort of looking to bring the people who would stay very, very far in the technical side a little bit more to the middle. So it's not really, the overlap is maybe not there of people that would be wanting to, the people who would already want to just devote their whole career to going into the social sector, by all means do it. This is for, I think this would be more for someone who kind of wants to dip their toe in the pool and then maybe go back to Google or Facebook or whatever, right? I think that's the difference. Yeah?
In terms of program design, which you are affecting in which area do you think that needs improvement the most?
In terms of program design, which area
That needs improvement the most.
what area needs improvement? What areas do you mean?
In terms of the whole 12-week packages, do you think there's anything to do better now?
The entire DSSG program, it's a 12-week program, right?
Yeah.
Which area needs to be improved more? That's what his question.
Do you mean within the curriculum? That's a great question. Okay, well, maybe just going back to the Hitchhiker's Guide, I think making this resource really sort of interactive and easy to navigate, because I've gotten a little bit of feedback from people that it's maybe not the most intuitive interface. So I think making this something that's a resource that people actually want to go to and find the information, but I think that we have a pretty good set of materials together. Not to pat ourselves on the back. All right. Please, if anyone else who has questions, please find me after this. I would love to talk more about it. Avishek's time to shine.
The final talk for this session is Avishek Kumar, who is going to talk to us about executive legislation.
So, complement to the DSSG program is the Applied Data Analytics course. And so this is a class that is a consortium between NYU, University of Maryland College Park, and University of Chicago. So your typical DSSG fellow is sort of stats, CS grad student, or like me, geophysicist. So in the Applied Data Analytics course, your typical student is a member of a nonprofit, local, city, or state government, and they're a working professional, so they're taking this class part-time. So this is our website. It's we just rebranded as the Coolidge Initiative. So typically, yeah. So the goals of the Applied Data Analytics course are the same as DSSG, to teach students how to solve real problems with data and how to communicate those solutions. Also to train a workforce to do this type of work, and then finally to give them the sort of tools to do that. And also to kind of expose agencies about examples of projects that can be done. So what we typically do is then what we need is the actual data for them to do these projects. So in DSSG, usually there's projects and projects partners. For the Applied Data Analytics course, we took a very different course. So what we did is we set up a secure environment to actually share secure data. And so it's called the ADRF, the Administrative Data Research Facility. So for the first class that we had in February, we received data from the Illinois Department of Corrections, and it had the 27 years of their admissions and exit data. And then we then received the data from the Illinois Department of Economic Security. So what we received was the wages that everyone had earned in Illinois, the quarter they had earned them, and the employer that had paid them. And we received data for the last 10 years. So then based on this data, we then created a curriculum around it. So the first thing we did is all the students meet in Maryland, and we've had a wide variety of students. We've had everyone from detective at the NYPD, chief data officer, and sort of a lawyer, all with a very different sort of technical expertise. So difference between DSSG and the Applied Data Analytics course is that there's a very large emphasis on developing a project. So we go over the sort of project scoping class that we had here yesterday in the tutorial, and then we divide the class into teams of 3 to 4 people. And that's to sort of balance out their skills. And then from there, they then decide on a question that they can answer with data. So we had 2 presentations yesterday about projects that were done in the first cohort. And so the first cohort's theme was criminal justice. So there's a question of, can you predict recidivism of offenders that recidivate due to technical violations, or can you predict recidivism of mothers? So from the sort of project scoping, they decide on a project. So then from there, we then actually have to give them the skills to see if they can actually do their project. So then that's where we sort of teach them how to use a computer. So we go over, so we're completely open source tools.
Can you speak up a bit?
Yeah.
Thank you.
So we go over open source tools, and so we go over Python, and then we try to beat the sort of stats and data out of them. So we chose Python over R because Python is actually just a robust programming language, so we can teach them the sort of basics of programming. So then we also teach them things like version control, so that they learn how to kind of archive their work, distribute their work, and collaborate with one another. And then we also teach them SQL. because they've never probably used database before, though we have had some database administrators. So then at that point, they can then look through the data we have and see if their project is actually feasible. Okay. And so then that's typically the first 3 days of the class. And then usually every few weeks, we then have a class meeting. Now everyone's a working professional, so they're working full-time while they're doing this. And so in the later classes, we'll have a class in Chicago at the University of Chicago, a class at the University of Maryland, and a class at NYU. And so then one group will teach, say, in Chicago, and then they stream it to the University of Maryland, or they stream it to NYU. So then after they sort of come up with a project, and then they have data, then we then sort of give them the tools to do this sort of work. So then we teach them about sort of GIS, sort of text analysis, machine learning, and record linkage, and then we teach them things about data visualization, which Alex actually teaches, and ethics and responsibility. And so, because we have a strong emphasis on teaching them to solve real problems, we develop our curriculum around the data set of the cohort. So in the first cohort of criminal justice, we would teach them things like how to do GIS analysis to see where people that sort of recidivate in prison, where they actually live in the greater Chicago area. Or for text analysis, we also taught them web scraping, so then they could scrape data from the web, and then based on that text data, we can then teach them how to use text data and text analysis and incorporate that into analysis. And then each group sort of did a project based on machine learning, where they were trying to predict some sort of recidivism. So typically we create code for them, and then they then adjust that code to do their projects. So the first class was about criminal justice, and everyone worked on projects at some aspect of recidivism. And then the second class, which was over the summer, was on welfare. So in that class, we had data from the Illinois Department of Economic Security. So then we have this 27-year history of everyone that's been on sort of welfare rolls in the state of Illinois. So you can do very interesting things with the data. So for instance, for network analysis, we were able to look at people who have recently left prison, and then you can see what actual jobs they get and how much money they're actually earning. So what one group tried to do is say if there's an actual kind of threshold of salary that could actually prevent people from recidivating. So then we had a lot of sort of rich data to work with. So by the end of the class, students have been able to track people longitudinally based on their time in prison, based on where they worked, and they were able to see if people that leave prison actually work again. Finally, they work on their projects throughout the class, and then they have check-ins with us where we have goals for them to hit. And so then the final project is they then present the final project to the people that have provided the data. So in the first class, it was the people from the Illinois Department of Corrections, and the second class was the people from the Illinois Department of Economic Security. And so typically the stakeholders are very happy about this because this is actually free work for them, and they've actually haven't asked these questions of their data, and they see the examples of what can be done in their data. But for me, one of the very rewarding things to hear about is, I had one student after the text analysis class, they then actually went and took the code, and they went and they figured out, they look at the feedback they get from their local airport. And so they were able to tag the feedback comments as good or bad, and they can find what all the sort of bad comments are, and they can actually find problems to fix. So it's the actual, for me, what's most rewarding is hearing about how the students use the tools we've given to them in their sort of everyday work in the public sector. So with that, you can go to this website, the Coolidge Initiative. We'll be having another class in the next 2 weeks that people have signed up for, and then we'll have another cohort in the spring that you can sign up for. And so there's a discount for people in nonprofits and the government, and there's also scholarships that you can apply for. And with that, are there any questions?
Is that data available to, like, do you have to be in the program to get access to the data that you're?
Yes,
yeah.
so it's kept in a secure facility.
And if I can, is this program geared toward, like I was looking at the requirements and it says you have to have a master's in like quantitative field. Yeah. So is this geared towards people who are in social sciences that want to learn more about data mining, or?
I am so sorry to interrupt, but this session has run 15 minutes long and the other two session rooms have started